All right, let's get right into it. We are going to deconstruct a pretty fascinating new patent from Tesla, one that could totally flip the script on how self-driving cars think. And I'm not talking about a simple software update here. This is, well, it's a whole new philosophy for how these cars make decisions on the fly.
So to really get why this is such a big deal, let me ask you something. Picture this, you're driving, and there's a huge puddle completely blocking your lane. Now what do? Do you plow through it? Maybe soak your car? Maybe splash some poor pedestrian on the sidewalk? Or do you peek into the oncoming lane, see it's totally empty, and just zip around it for a second? See? There's no textbook right answer, is there? It's all about judgment, it's all about context.
And that kind of judgment is exactly what we're going to break down. We'll start with that driving dilemma. Then we'll look at the old way of trying to solve this, which created a big prediction problem. After that, we'll dive into Tesla's solution, this new kind of map. We'll see how it scores its options, how it prunes the bad ones, and then we'll wrap up by talking about why this system is super clever, but maybe not truly conscious.
You know, Tesla's own head of AI actually calls these things mini trolley problems. And it's the perfect description, right? They're not these huge, dramatic life or death choices, but they are these constant, complex, little trade-offs that old-school, rigid, rule-based systems just completely choke on.
I mean, just think about your own driving. It's not just stop at red, go at green, right? It's thousands of these tiny little judgments. Should I speed up a tiny bit to let that car merge? Should I hang back from this guy who keeps tapping his brakes? The real honest-to-God challenge for AI isn't just avoiding a crash. It's making decisions that feel, well, that feel human.
So how do the old systems try to handle all this? Well, that brings us right to the core problem, the technical reason this patent even exists. Okay, so the old way was basically to try and be a fortune teller. The car's computer would attempt to predict the exact future path of every single thing around it, every car, every pedestrian, every person on a bike. I mean, can you imagine? Trying to calculate all those possible futures is it's a processing nightmare. It's incredibly slow, and it's what leads to that super cautious, almost robotic driving we've seen, where the car slams on the brakes for no apparent reason. It's just overwhelmed by all the what-ifs.
So Tesla's new patent basically looks at that whole fortune-telling idea and just tosses it in the trash. Instead, they're introducing something totally different. It's called a hierarchical nodal graph.
Okay, and this is maybe my favorite way to think about it. A fantastic analogy from an analysis of the patent. It's like a raid leader in World of Warcraft. Think about it. A good raid leader doesn't predict the exact mouse click of every single player in the group. That's impossible. Instead, they evaluate strategic options in real time. Okay, everyone, stack up over here. Get out of the fire. It's a huge shift from predicting the future to just evaluating the best move for the present moment.
And that's exactly what this graph is. It's a decision map. So instead of guessing where every other car is going to go, the system maps out its own possible choices, these things it calls nodes, and just figures out which one is the best option right now. Simple as that.
So let's see how this decision map actually gets built. It works in 3 really clean layers. At the very top, you've got the main goal. Something simple, like, I need to get into that left turn lane. Simple enough? Then you have the different paths you could take to get there, the actual trajectory of the turn. And then finally, you get down to the nitty-gritty, the interactions. These are the specific things you have to do along that path, like yield to the person in the crosswalk. It's a really smart, elegant way to break down a super complex decision.
Okay, so the car has this map of all its choices. Cool, but how does it actually pick the best one? And more importantly, how does it do it fast enough to be useful on a real road? Well, that's where 2 key ideas come in: scoring and pruning.
So every single possible choice, every node on that map gets a score. And that score is based on 4 things that the AI has learned from watching millions of miles of real humans driving. It's asking itself, 1, how smooth is this ride going to be? Is it comfortable? 2, how likely is it that a human would freak out and grab the wheel if I do this? The intervention likelihood. 3, can the car actually physically do this safely? And 4, and this one's key, does this just feel like a normal human thing to do?
Now, with all these options being scored constantly, the system has to have a way to think lightning fast. And the secret sauce, the little trick that makes it all work, is something called dynamic pruning.
So just imagine for a second, the car is weighing 3 different paths. Path A looks great, it gets a score of 95. Path B is, all right, it gets an 82. But path C, well, path C is a dud. It only scores a 31.
And here is the absolute genius of it.
the system doesn't waste a single extra nanosecond thinking about path C. It's instantly pruned, just snipped right off the decision tree, gone. And this lets the car's brain focus all of its power on the choices that actually matter, the high-scoring ones, and that's what makes it so incredibly fast and efficient.
Okay, let's pull all this together. What we're looking at is a massive leap forward. It's more efficient, it's more human-like, it's a breakthrough. But, and this is important, the patent itself reveals some pretty clear limits to this approach.
And this slide just lays it all out perfectly. We've moved away from the slow, clunky fortune teller that's trying to predict everybody else. Now we have this fast, efficient decision map that evaluates its own choices in the moment and scores them based on values it learned from us. It is, fundamentally, a much, much smarter way to attack the problem.
But, and yeah, it's a big but, the analysis of this patent points out a critical limitation. It describes this system as having an animal-like reactive intelligence, and specifically states it's not a system that's capable of higher-order reasoning.
So what does that actually mean? It means this system is an absolute master of the present moment. It can react brilliantly to whatever its cameras and sensors see right now. But it has no memory. It can't remember that the road was closed for construction on your street yesterday, so it's probably still closed today. It doesn't get the bigger picture, the deeper context. It is pure, powerful reaction.
And that leaves us with the really big question, doesn't it? This new system is undeniably clever. It's efficient, it's a huge step in the right direction. But when we think about the future of our roads, with all their chaos and unpredictability, is a brilliant, animal-like reaction good enough? Or do we ultimately need something more?